Okay. All right, we do have one school joining us online. I'm hoping that there might be some others, that there meant to be some more, but we'll see. So it's all good. Right, so today we're going to be doing some algebra, and this stuff is really, really important. Okay, so let's take a look. We're going to start off just with some products, and I want you to try and, is this working? Guys, are you hearing me okay? Yeah. I want you to try and understand your maths, because everything that we're going to do today, every single thing makes sense. Izibalo, zitrateka injalo. Okay, it always makes sense. Suppose you going, and I'm going to write this on your blank page at the front. You'll see that you've got on the back inside of the cover over here, you've got some blank page, and I'm just going to show you something. Okay. If you go to the shop, all right, and you're buying, let's say you're buying a Coke, and maybe the Coke costs 10 Rand. Okay. And maybe you're also buying some chips. Maybe the chips cost 6 Rand. Okay. Now, as you're at the shop and you're about to pay, you see your friend. Okay. Now, the shopkeeper could either say 10 Rand plus 6 Rand. That's how much we've spent so far. How much is that? 16. Okay. And the shopkeeper could then say, let's double that, because now you're buying for your friend as well. Okay. So we would get 2 times 16. Norma, the shopkeeper could say, let's take 2 times 10, 2 Cokes and 2 chips. Okay. And will you get the same answer? You must get the same answer. It makes sense. So it's going to be exactly the same whether we add the Coke and the chips and then double, or whether we double the Coke, double the chips, and then add. This one comes to 20 plus 12. Final answer, 32. This one comes to 32. It makes sense. Okay, now what we've learned here, what we've shown here, what we understand here, all right, is that we've got this law of mathematics called the distributive law. Okay, and I know it's much harder for you guys to learn maths and some of this terminology because of the language. Okay, but what the distributive law says, okay, distribute means to share. Ngingasho kanjani ukuthi share ngesiZulu? Share. Okay, you guys know. I don't know. I'll have to ask Ayanda to teach me how to speak isiZulu. Okay. All right. So, guys, watch what happens here. This 2 shares there and it shares there. Okay. Now we're gonna look, and I'm gonna ask Ayanda to walk around with the microphone, and she's just gonna, maybe you'll put your hand up, but maybe she will just pass you the microphone and say, tell me the answer to this. This first one is very easy. Just give the microphone to anybody here. Give it to Asanda here, right in the front row here. Asanda, do you want to tell us what happens when we multiply, when we distribute this in here? What are we going to get, Asanda? Do you want to tell us or not? Uyasaba? No, tell us. Sorry? Okay. What's 2 times x? 2x plus 6. Okay. All right. Okay. Now, just now I was talking about going to the shop and I said, maybe there's a Coke and there's chips, but maybe there's more things. Okay. So now we've got the 2. It needs to multiply by everything here. I want to give someone the microphone and ask them to tell me the answer here.
2a plus 2b minus c.
Halala uyinqobile. Okay. All right. Okay. Now I want to show you something here, because you might have been taught by your teacher some little rule. We'll talk about it just now, foil or something, Angazi. All right. But I want us to think about this as one thing. Okay. That yellow blob. Okay. If I've got, and you're gonna think, hey, now Paul's lost it completely. But if I've got blob times by C plus D, what will the answer be? Who can tell me? It will be blob times C plus blob times D. It's exactly the distributive law. So now, what are we going to do? We're going to do exactly that here. We're going to take this blob and we're going to multiply it by C. And we're going to take the blob and we're going to multiply it by D. Okay? Now, normally, you might say to me, Paul, normally we have the number at the front. So you might say, let's write it like this. Is it okay to swap a multiplication sign around? In other words, to put the C in the front and the A plus B in the back. Is that okay? Yeah. What's 5 times 7? Wait, me. 5 times 7, guys. 35. Yeah. You need to know 5 times 7 is 35. Yinile. In Komish. Yeah, this is a cup. You don't have to think and count on your hands to know that this is a cup. In Komish. 5 times 7 is 35. You must know that like you know your own name. Okay. Yeah, those learners, guys, those learners that are in a row there, if you can just move to down the bottom there. The teachers, if you want to, these back panels open up. Yeah, Tabo, maybe you could just check. In the middle, you can open this back section from the outside. And then the teachers can sit in the very back row. Like, in other words, outside. I'll come and do it. I'll come and do it just now. Okay. All right. And I can do the same thing. Sorry, guys. I was saying 5 times 7 is 35. What's 7 times 5? 35. Hala. Okay. Now, D times A plus B. All right. So what's the final answer going to be here? CA plus CB plus DA plus DB. And what we see, guys, is that everything in this bracket multiplies by everything in that bracket. Have a look. The C and the A multiply. The A and the D multiply. The B and the C multiply. And the B and the D multiply. So there's actually 4 terms, okay? Because there's 2 terms, each of them multiplying by 2 terms. 2 times 2, there'll be 4 answers. Okay. Some of your teachers, I don't know, have you guys heard this FOIL thing? Yeah, maybe. All right. The A times the C, we say that's the first one in each bracket. The A times the D, that's the outer pairs. The B times the C is the inner pairs, and the B times the D is the last one in each bracket. So a lot of teachers teach first, outer, inner, last. You don't need to do that. What you need to remember is that everything in the one bracket must multiply by everything in the other bracket. So now I'm looking for an answer here. All right, and I'm going to ask Ayanda to get an answer. Here we go. We've got someone who's got their hand up. Yes. My wife is there. Thank you. Okay. I want you to tell me what's going to be and I'm going to give you a hint. They're going to be 6 terms, okay? But everything must multiply by everything else. Tell me what you've got. A, yeah, AC plus AD.
AE.
Yeah.
Plus BC.
Allah. Well done. Okay. Okay, right. So I've written it there. If we've got everything must multiply by everything. Now we've got 3 brackets, okay? So what we're going to do, we're going to leave the a plus b outside on its own for now, all right? And then I'm looking for someone who can tell me what will this be if we multiply c plus d by e plus f. So I'm just looking at this piece. What do we get?
3e
Yep,
plus 3f
yep,
plus de
yep.
plus df.
Plus df. Okay, and my bracket's too close, so I'm going to have to rub this bracket out. Okay, all right. And I want a bit more yellow here. Okay, now, who can tell me what are we going to get now when I multiply a plus b by all of these things? And I'm going to give you a hint, guys, because in grade 12, and the teachers in the room will be interested to kind of understand this little link. In grade 12, we talk about how many possibilities we're going to get. We do something called counting techniques. How many terms are there in this bracket? 2. And in this bracket? 4. If we multiply 2 times 4, we're going to get 8. I'm going to tell you that there's going to be 8 terms in the final answer. Anyone want to tell me what they are? Okay. Yeah, there we go. Anyway, I did see a hand up. Okay, there we go. All right. Yeah, I just given the microphone to someone that they are not sure, but that's fun. You're going to take the A. You're going to take the A and you're going to multiply it by. Okay. You're going to take the A. You're going to multiply it by that, by that, by that, by that. Okay. Here we go. Someone's got the microphone.
ACE
Yep.
plus ACF plus ADE plus ADF plus BCE plus BCF plus BDE plus BDF.
So BDE plus BDF. Well done. Hala, hala. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we should be able to multiply anything together. Okay. Now, what I want you to do here, look at this answer. Look at these 3. Okay. This one, we're going to work out. Then you don't need to start from scratch with this one because this one, what does x plus 3 cubed mean? It means x plus 3 times x plus 3 times another x plus 3. So from this one, we're going to have x plus 3 times by x plus 3. Okay, now, the single biggest mistake, let me tell you, the single biggest mistake that people make in mathematics is this one. People say x plus 3 all squared equals x squared plus 9. This is wrong. Okay. And if, guys, let me tell you something interesting. If I had 1 rand, Elinodwa, 1 rand, every time I saw this error in my teaching career, I would be a multi-millionaire. I would have millions and millions of rands. Okay? And do you know what I would do if I had millions and millions of rands? Anybody want to tell me what I would do if I had millions of rands? Buy a new car, maybe. Buy a new house. No, you know what I would do? I'd carry on teaching you guys maths because I love teaching maths. Okay. All right. Guys, this is not right. Who can tell me what do we need to do here? Yeah, there's some hands here. Yeah. Thank you.
The first step we do.
Okay. So x plus 3 and? Okay. Because that's what squaring means. It means multiplying by itself. Yeah. Yes.
The second x
Yeah.
the second step would be
Plus 9. Okay. All right. And so now what's the final answer? La. Okay. Okay. Now, guys, I want to talk a little bit about this. When you do this, If your friend does this, you must, oi! Okay, because they have forgotten, okay, the outers and the inners. Okay, now, I want you to go back to this blank page over here, because this, squaring a binomial, is something that we're going to do very, very often. Okay, now, I want you to look at what's going to happen here. We're going to go a plus b, and so what's it going to be? A squared plus AB plus another AB. So I'm going to say plus 2AB plus B squared. I want you to look here for the pattern that's existing. Maths is all about patterns. The middle terms here, we always, when we're squaring, we always get 2 of the product of those things. Okay. So now let's see if we can write down straight away the answer to this in one go. Because squaring a binomial, you're going to do this hundreds of times in your between now and the end of grade 12. You're going to do this hundreds of times. So let's get good at it that we can just write the answer down. Okay, anybody want to just take the microphone and tell us what's the answer going to be for x plus 4 all squared? Yeah, here we go at the front here. So, okay, we got it. Someone at the back there. Yeah, great. Thank you. No, I don't want you to do that. I want you to go straight to the answer. In other words, I want you to use the pattern that we've established. Yeah. Yeah. I want you to go straight to the answer. Okay, that's wonderful. Well done. I actually want you to be able to go straight from here to here, guys, because this piece is this times 2. Does it make sense? It always makes sense. Okay, what about this? X plus 5. Who can tell me the answer, the final answer straight away? Ayanda's going to have her discovery steps for vitality. She's going to do 10,000 steps today easily. Yeah. Yeah. Halala. Uyingobile. Okay. All right. Now, let's do another one. Someone, anyone. Look for the pattern. Guys, this here was this times this doubled.
Squared minus 6x plus 9.
Halala. Okay. All right. Now you're going to think how Paul is now, he's losing it completely. But look at this. Because it's all about pattern. Ikaya plus inhlanzi squared. Who can tell me what's the answer going to be? I want someone to put their hand up and tell me. There's a few people saying it. Here we go. Yebo. Yebo. Not Ellie Lordward. 2. Okay. 2. Sorry. 2. Let's put it as you saying it. 2. Ikaya inhlanzi. Halala. Okay, guys. So that's a pattern. And it's really, really important because later we're going to teach you a thing called completing the square, and we're going to go the other way. We're going to go kind of backwards. And if you've got that pattern stuck, then that's great. So now this one, actually, all right, I'm back on your guys' page 3. All right, this one, actually, I can write down, even if I hadn't done the one on the left, I can write the answer straight down for this, can't I? What's it going to be? X squared for the two brackets, x squared plus 6x plus 9. And that's what we got. That's what we got over here, obviously. Okay. Now, who can tell me, and you don't have to do it in one go, who can tell me what will the answer be when I multiply this thing with 2 terms by this other thing with 3 terms? I'm giving you a hint, there's going to be 6 terms. Okay.
It should be x cubed plus 6x squared plus 9x plus 3x squared plus 9x plus 9x plus 3 squared.
Okay, I lost you a little bit there, but you absolutely... Did you say plus 9x? I'm not seeing the 9x. I'm seeing... What's 3 times 6? 18x. And at the back, I think you said 27. Can this is right. Can it simplify? How's it going to simplify? Yeah. Okay. 27x, yeah. Hala. Okay, well done. All right. Okay, and then guys, the last one here, look what's happening now. Okay. If you've got this, we cannot multiply this 2 inside the bracket here and then cube it, because I want to show you something here. What is 2 times 1 cubed? What's the answer to this? It's 2. If you say to me, Paul, let's do this, is that the same thing? No. Later this morning, we're going to talk about exponents. This is different because now the 2 is being cubed as well. So this is not what we can do here. We've got to work out x plus 3 all cubed, and then we've got to double our answer. Look at this. Multiply every single one of these terms by 2. Let's just say it together. What's it going to be? 2x cubed plus 2 times 9, 18x squared, 2 times 27, 54. All right, guys. 2 times 20 is 40. 2 times 7 is 14. 40 plus 14, 54. Some people say to me, Paul, you're clever. You can do all this maths in your head. I'm not clever. Do you know why I can do it? It's because I've had lots of practice. It's just about practicing. If you use your calculator to multiply 5 times 7, your brain is not going to improve. Okay? You need to use your brain for it to get better. You guys understand this. If you go to the gym, especially the boys, maybe they go to the gym, they want to be nice and strong. They pump iron. What happens? Your arm gets stronger if you use it. If you don't do any exercise, your muscles and your body gets weaker. It's exactly the same with your brain. Okay, now, I want to show you something here. If we are taking 9 away from 11, what is the answer? It's 2. Okay. If we say, let's write 9 as 5 plus 4, is 9 5 plus 4? Yes. What is the answer to this sum on the right-hand side here? It's not 2. Careful. Yeah, it's actually 11 minus 5 is 6 plus 4 is 10. So these two things are different. When I change the 9 into 5 plus 4, I need to put it inside brackets. Okay, because otherwise I'm not taking away all of it. Okay, because this is actually minus 5 minus 4. And this answer is 2. Okay, so these two on the left are the same, but just bustle up, huh? Because if you don't put the brackets, you're going to get a different answer. And this answer is not 11 minus 9. This answer is 11 minus 5 plus 4. Okay, now the reason for this is I want to show you now, we're going to simplify some stuff here. Okay, we're going to start off with this one. And I want someone to talk me through it. You don't have to give me the answer straight away. Maybe 2 lines, and then we'll get the answer. I'm looking for a volunteer. Great, we've got lots of volunteers, guys. It's wonderful, because one of the things, just before you talk, one of the things that we want to try and develop in you is confidence. Okay, because one day you're going to go for a job interview, all right, and they're going to say to you, "What's your name?" And you don't want to be saying, "My name's Londi." Okay, you want to say, "Hi, I'm Londi, and I'm here to get this job." Okay, all right. So Londi, talk to us. Tell us what we're going to get here.
Yes.
Yeah.
Sorry.
Yeah.
Minus
Yeah.
plus three.
Okay. Final answer.
Minus 3x. Minus
Well done. Hala. Okay. Now, guys, often you look at a question like this, and a lot of people, they get scared, mind you. They're saying, yes, but okay, because it looks quite big. But this is just some steps, okay? So what we're going to do, and who can tell me what's going to happen here? And I want you to multiply these 2 brackets. I also want you to multiply these 2 brackets. I want you to, someone tell me what we're going to get. Yeah, over here.
X1
Yeah.
minus 3x plus 3x minus 15 minus x1 minus 3x minus x plus 3.
Okay. Now it's in Kinga, and I'm going to tell you why there's a problem, okay? When this thing, do you remember what we did on the previous page here? When we took away 9. When we made 9 into 5 plus 4, we got more terms. Okay, now I want to show you what's happened here. How this here is one term, elilodwa. Okay? When you multiplied it out, it became how many terms? 4 terms. Which of them need to get subtracted? All of them. I heard one person say all of them. Basopa. Okay. We need to have that in brackets. Do you see what's happened? Okay. So, and that there, very, very common error that people make. Okay. All right. So now, if you still got the microphone, you can carry on for us. Okay. And tell me what are we going to get now? Okay. And I'm sorry, guys, I haven't left much space for this question, but okay. What's it? Just simplify this one. What's it going to be? X squared?
X1
Yeah.
minus 7x.
Okay. So, well, you've got minus 7x here, and then it's going to be minus 7x. Minus 6. Okay. Cool. And now let's go for a final answer.
Minus 21.
La. Okay. Now, guys, I'm going to show you something. Okay. And you might be surprised that I'm going to show you this, but it might take a little bit of time. I hope it's not going to take too long. I'm going to do something on my phone here. All right. And I'm going to show you. Let's go here. Okay. Okay. So what I'm doing is I've got my phone showing something here. Okay. And I'm hoping you're going to see, hoping that this is going to work properly. Yeah, I don't know why this is. It's streaming. Okay, I think it's working now. We'll see. Yeah, it is working. Okay. That picture in the background, you can just see that picture in the background is my daughter and my son-in-law. They got married. So yeah. So yeah. Okay. Now, guys, what I'm going to do, all right, I'm going to show you here an app that I've got. Okay, it's not there. An app that I've got on my phone that you can download for free. It's called Photo Math. Okay, so there's the app. Now, what I'm going to do, all right, I want you just so Asanda, just bring me your book. I'm going to take a picture of this question, okay? Just this question here, and I'm hoping Sandra's written quite close to it, so I'm hoping it's going to work. Okay, did you see? 5x minus 21. What answer did we get? We got 5x minus 21 as well. Okay, all right. How can the software on the app do that? The reason it can do it is because maths is all about rules. That's why you can program a computer to do this question. It's all about rules. Okay. So now I want you guys to try. I'm going to give you just a minute or two. I want you to try question C. All right. And question D. But I want you, when you do question C, guys, are you able to just write the answer straight down for x plus 4 all squared? Yes, because remember Ifish and Inchlanzi and Ikaya. Do you remember that? Yeah, you know the rule for that. Okay, so let's try C. If you finish C, you can try D, and I'm going to look for answers from both of those just shortly. Check with your friend. Check with the person next to you if you've got the right answer. Let me tell you, you can't get different answers. Okay, I'm going to play you a little piece of a song. Okay. I'm going to find the song while you guys are working. Keep working. Okay. I want you just to listen to the words of the words here, and you'll see the words are written. Okay, so they're saying two men say they're Jesus. One of them must be wrong. Okay, they can't both be Jesus. You can't get different answers to this question. If you've got a different answer to your friend, one of you is wrong. Okay, I'm looking for an answer for this question. Yes, thank you. Is that your final answer? Okay, I'm not photo maths. I'm not clever enough to establish that straight away. Can you tell me what your sort of next step, your step over here was? And I want you to try and do x plus 4 all squared in one go, because I've only got one line here. Yeah. Yeah. Okay. So now we must either put some brackets in. All right. Just tell me what is x minus 3 all squared when you square? It will actually be minus, because I've put that minus still there, it'll be minus 6x, won't it? Plus 9. Okay. Guys, if you take the brackets out straight away, that's fine. Then it'll be plus 6x and minus 9 and minus x squared. Okay. I'm going to check your final answer, and I'm not sure that it's right. Okay. Because how many x's have we got? I've got 8x and is it plus 6 or minus 6? It's plus. So ukotliwe the brackets. Am I right? Okay. And then the 16, it's 16 minus 9. I'm interested because you actually got that 7 is correct, but this 2x is not correct. What should it be? It should be 14x. Okay. 14x. And guys, don't feel bad if you make a mistake. We learn by making mistakes. All of us learn. We learn from each other's mistakes. We learn from our own mistakes. So you mustn't don't be scared to try, and don't feel bad to make a mistake. All right, I'm looking for an answer for D now. So right down at the front here. Is it Sibongile? So I got my eyes on. Sorry, what's your name? Is it Sibongile? Yeah. Sibongile is going to tell us how to do this one. So, X4, guys, what we say, because math, yeah, you can either say exponent 4, or you could say x power 4, or you could say x to the 4. But when we say x4, that's not it. Okay. Okay. Yeah, but I know what you mean. Yeah. Okay. Minus 4x cubed. It's fine. It's fine. Are we going straight to the final answer, or no? So I think what we must try and do here is be systematic. So you took this x squared and you multiplied it by x squared. Then you took x squared and you multiplied it by minus 4x. Then I think you started doing some other things. Let's rather stick with this x squared. What will we get when we multiply the x squared by the minus 1? Yeah. Okay, carry on. Sorry, maybe I wasn't listening properly. Okay. Now what are you going to do? Well done. Good. I'm just going to quickly show people what you're doing now. What you're now doing is you're taking this one and you're multiplying it. Yeah. Okay. So carry on. 3x cubed. No, I'm happy with that. 3x cubed minus. Oh, no. What's this one going to be? Minus? Yeah, 12x squared. Yeah. And then minus. Correct. Minus 5x squared. Yeah. 20x. Yeah. Plus 5. Okay. Now, we've got a whole lot of like terms. Ooh. Are you ready to give me your final answer? Okay. Yeah. Yeah. So I'm just going to check. We've got minus 1 there, minus 12 is minus 13, minus, what did you say, minus 18? Yeah. Okay, I'm just looking for where the x's are going to come from. We've got minus 3x plus 20x. What should it be? It should be plus. Correct. Allah, Allah. Well done. Okay. I think a round of applause. There's a lot going on there. Okay. Right. So I'm going to leave the next two. They're just more of the same. Okay. And we're going to get onto now factorizing. Okay. And factorizing, this is the thing with mathematics. You can't do factorizing if you can't do products. If you think of a coin, products on one side of the coin, factorizing on the other side of the coin. Just now we were going, if we've got 3 brackets x minus 2, what would that be? 3x minus 6. Now, that's a product. This is a factor. When we factorize something, we take it from many terms, look here, 2 terms, to 1 term. This is only 1 term, elilodwa. Okay, we are basically going backwards. And what we're going to look for is the highest common factor. So over here, it is going to be 3. What must go inside the brackets? X minus 2. Okay, cool. All right, now, so I'm hoping that as Ayanda walks around the room, she's not writing any blank workbooks, guys. Because if you are not writing anything and you don't want to be here and you only came for the tea and the lunch, then don't come next time. Rather, because, guys, there are schools. There's a school called Amashrubi, big school near Escourt, near Mchezi. They can't come today because there's not space. So all I'm saying is if you are here, take advantage of it. Okay. Don't waste the time and waste the money. Okay. I'm looking for an answer here now. So I'm looking for a highest common factor. Okay. And I'm going to check your answer by multiplying back. Yeah. Tell me what you've got. Two minus. So x minus 2 y squared. Is that all? Okay. Now, what we're going to do now, I'm going to check because I know how to multiply. And so this times this is going to give me 4x cubed yp, halala. And this times this is going to give me negative 8 x squared y cubed p, halala. Done. Okay, well done. All right. Okay, guys, what we've got to just be careful of is, have we got the highest common factor? Because it's possible, let's say that you had left, well, we'll see it. We're going to come across it soon. Okay, now let's have a look at this one. I'm looking for a volunteer to tell me the answer to this one. I'm looking for a highest common factor. Yeah. Okay, I'm not sure if it is, but I'm going to write that down. And well done, and we'll see. Minus what? Yeah. Okay, now let's have a look at this. 4xy squared times 3x squared is going to be 12x cubed y squared. Well done. Is this one important? Do I need this one or can I leave it out? It's very important. If I don't put the 1 there, I'm not going to get this term. 4xy squared times minus 1, halala. And now 4 times 2, 8, yes. X times x cubed, x to the 4, yes. And y squared times y. Well done, halala. All right. Now the next type of factorizing, and I'm hoping the teachers are also watching and the order in which I'm doing this factorizing. The next type of factorizing is actually the same one, but is there a common factor in all these 4 terms? In all of the terms? No. Okay. What can happen here is that there can be, all right, there can be a common factor in some of the terms. Who can tell me what, if I look at the first 2 terms and I take out a common factor and I look at the next 2 terms and I take out a common factor, who can tell me what's my answer going to be? Yeah, okay. Okay, I don't want the final answer. Okay. No, so what's the common factor here? Is 3. And then? Yeah. Yeah, plus C, yeah. Okay, halala. Now just yimagangani. Okay. How many terms were there in the question? There were 4. How many terms are there now? 2. Is there a common factor in these 2 terms? Yes. There it is. Okay. So tell me your final answer now. In brackets, huh? Yeah. Well done. This, guys, this here is the common factor. Remember earlier today, I called it a blob. And I said, what we've got 3 blob plus C blob. The common factor is blob. Blob, open brackets, 3 plus C. Right. I'm looking for the steps in this one. I don't want the final answer. Yeah, I want you to tell me what's it going to look like. If I take out the D,
D, open brackets,
yeah,
equals F plus E.
F plus E. Have we got a common factor?
Yeah.
Is E plus F the same as F plus E? Yes, guys. What's 2 plus 4? 6. What's 4 plus 2? 6. This, guys, just listen to this. Addition and multiplication are commutative. What commute means is to travel, okay? So if they swap, that's okay. All right. So what's your final answer now? Yep.
True.
Well done. Okay. Excellent. Okay. I'm looking for someone to help me with this next one. Now, this next one's got 6 terms. Okay. So we're going to look for common factors maybe in the first 2, and then in the next 2, and then in the next 2. All right. And it doesn't matter if you don't get the final answer, even if you can just get us started with this. Someone. Yeah.
Open bracket A minus 2 plus bracket
Yeah.
plus D. Open bracket A plus 2.
A plus 2 or A minus 2.
D. Open bracket B plus 2 plus bracket plus.
What? So I've lost you. So I'm over here. So C open brackets A minus 2. And then what about this one? What's the common factor?
What?
So I don't want you to do, I don't want you, I just want you to take out the D for now. Just careful, just listen again. So You said 2 plus D. It won't be 2 plus D. What will it be? Okay. Better, but is it plus or minus? It will be minus, won't it? Okay, 2 minus A. Okay, thank you. All right, now, sorry. 2 minus A. Okay, now, guys, is A minus 2 the same as 2 minus A? No, it's not. Listen to this carefully. What's 5 minus 2? 3. What's 2 minus 5? -3. Now, I don't know them. I've been teaching for a long time, but I don't know what we're going to call this. So I've got a name for it. I call it a switcheroo. Okay. What we're going to do now, because we saw 5 minus 2 is the same size as 2 minus 5. Norma, the one is positive, the other one is negative. All right. What we're going to do, we are going to leave this as A minus 2. We're going to leave this one as A minus 2. Cordwa, we're going to change this one to A minus 2. And when we do that, we must change the sign in front here. So it's going to be minus D, A minus 2. I want to show you that when you multiply negative D by A, what do you get? Negative AD. And when you multiply negative D by negative 2, what do you get? Positive 2D. This is the same as the line above. This equal sign, it's exactly the same. How many terms have we got now? We started off with 6 terms. How many terms are there on this line? 3. Is there anything that's common in all the terms? What is it? A minus 2. There. Think of it like a blob. I've got 2 blob plus C blob minus D blob. So my answer is going to be blob. And then it's going to be 2 plus C minus D. Does it make sense? It always makes sense. If you wanted to, you could check by multiplying back. A times 2, 2A. A times C, AC. A times minus D, minus AD. We've got it there. Minus 2 times 2. What's minus 2? -4. There it is. Minus 2 times C, minus 2C. There it is. And minus 2 times minus D, plus 2D. Okay. All right. So this idea, I've written it here. Maybe you want to put a star next to it. Ebalulekile. Okay. I like to call it a switcheroo. Okay. So I want you to try. Now, I want you to try number A. Everyone try number A. Okay, we've got a hand up here. I think this is Injaloba. Okay, no, she's not coming to you yet. Am I right? Is that Injaloba? Your hand was up. Yeah. Ayanda is choosing people for us. This is Doorncliffe, eh? No, is it Doorncliffe? Yeah, you must tell us where you are. Tell us your name also. Tell us how to do this question. Okay. 3. Okay, 3 open bracket. Yeah. Yeah. Okay. Yeah. No. Yeah. Open bracket A minus B. Okay. So it's actually, that's the final answer. Okay. Well done. Okay. What we've done here, and you've done it in one go, and that's absolutely fine. You've done the switcheroo here to make this minus D, A minus B. Do you see what's happened? The B minus A has changed to A minus B, and the sign in front has changed. You don't have to show this orange step. Okay? It's correct. Well done. But don't get it wrong. Okay. Right. Now let's look at this one. Okay. It's already, how many terms has it got? It's got 2 terms. Is there a common factor at the moment? No. There's a 2 minus x, there's an no, there's no common factor. Who can tell me what will I write down now if I'm going to leave this as 2 minus x? A plus b. I want to change this one to 2 minus x. C plus d. What must I do here? I must make this negative. Okay, I've done the switcheroo there. Now, there's still two terms, but have I got a common factor? Yes, what's the common factor? 2 minus x. That's all okay. Okay, so think of it like a blob. Blob times something minus blob times something else. I'm going to take out the common factor of blob. It's going to be 2 minus x. What must go inside? Now, careful here. What must go inside here? A plus b minus, like that, I corner. Okay, guys, look at it. It's a plus b minus all of c plus d. So I must put brackets here. Norma, I can write this as 2 minus x. If you don't want those brackets, 2 minus x it will be a plus b. If I take this brackets out, it's going to be minus c minus d. Okay, so far we've got one type. It's actually only one type of factorizing, common factor. Okay, that's the first type, and it's the first thing we always check. Now, step number 2, if we've got two terms, when we count the terms, if we've got two terms, there's 3 different things it could be. Okay. Pendule ikas. Okay. The first one is called a difference of 2 squares. Maybe your teachers are saying dots. Okay. And when we've got a difference of 2 squares, it can factorize. Is everyone okay with what we're saying here? Difference means a minus sign. And squares, amabili. 1, 2 squares. Okay. It will factorize like that. Okay, I want you to write down some other ones here. I want you to write down x squared minus 9 equals. And I want you to tell me, is that a difference of 2 squares? Yes, because 9 is what? 9 is 3 squared. So how will it factorize? X minus 3, x plus 3. Does it matter if I'll go x plus 3, x minus 3? No, because multiplication is commutative. You can swap it around. Okay. All right. I want you to write down another one. Is this a difference of 2 squares? What will it be? Add x squared plus 5. Okay. I want you to do another one for me. And I'm looking for an answer now, so maybe you can find the microphone and just tell me, what is this a difference of 2 squares?
X
Yeah.
minus x plus 1.
Allah. Okay, well done. Right. Okay. Now, I want to just check something here, guys. Is this here a difference of 2 squares? It is. Okay, because 6 can split equally. It's an even number. So this question can actually go one step further. We can go x, I'm looking for an answer here. Notice I've still got to write the other bracket down. The x to the 6 plus 1 must still be there because I'm saying it's equal to the line above. Okay. I think you said 6. I think you meant x cubed. It's x3. Yeah. Okay. Hello. Now, guys, and you might need to write this up at the top of the page here, but I want you to write this down. And maybe you want to write this on a piece of paper, a big piece of paper, and stick it on your wall at home. Ebola squared minus lightning bolt squared. What's it going to be? Ebola minus lightning bolt, Ebola plus lightning bolt. Okay, and you'll see just now why I'm using these symbols, because it's just about patterns. Okay, there's 2 more types if there's 2 terms. One is called a difference of 2 cubes, and the other one is called a sum of 2 cubes. And I want us to look at the pattern of what's happening here. Look here, a cubed minus b cubed. What you do in the one bracket, you just have a minus b. You just write them down without the cubes on. In the other bracket, you have a squared, you have b squared, and then this, guys, look at this. This here is the product of these 2 things. Cordwa, we change the sign. So instead of it being minus, it becomes plus. Look here. This one is exactly the same. We drop the cubes. In the middle here, we have this product with the sign changed. So I'm going to ask you to write down a few of these now. Okay, the first one I'm going to ask you to write down is x cubed minus y cubed. Okay, and let's see what we're going to write. It's going to be, let's just watch with me as I do it. The first thing I do is I just write it down without the cubes on. Okay, next door here, I put x squared and I put plus y squared always. And then this piece here, I'm going to take this times this, but I'm going to change the sign. So it'll be plus xy. Okay. All right. Now, let's do another one. I want you guys to try and do this one. A cubed minus 8. Is 8 a perfect cube? Yes. What is it? It's what cubed? It's 2 cubed, yeah. So in my one bracket, what am I going to write? A minus 2. In the other bracket, I'm going to write a squared. At the back, I'm going to write 2 squared plus 4, okay? And now what's going to go here? Well done, plus 2a. I take this product and I change the sign. Okay, I'm going to ask you to write this one down. Oh, goodness. Kaya cubed minus Inhlanzi cubed. Okay, so in the one bracket, I'm going to have Ikaya minus Inhlanzi. And then here I'm going to have Ikaya squared plus Ikaya Inhlanzi. And I'm going to have at the back plus Inhlanzi squared. Okay, all right. We're going to do a sum of cubes. I'm going to ask you to try and do this one. G cubed plus 1,000. Is 1,000 a perfect cube? Yeah, it is. I'm looking for someone with a microphone to give us an answer here.
G plus 10.
Yeah.
G squared minus 10G.
Yeah. Sorry, this thing thinks I want to draw a rectangle. Yeah. Minus 10G. Yeah.
Plus 100.
Well done. Hala. Okay. All right. Okay, guys. So these are not too bad. Okay. All right. Now the problem is we're going to start mixing them up now. Okay. But I want us to try some of these. But remember, the first step of factorizing is to look for a common factor first. Okay. All right. So I'm going to ask you to try all of these. I'm going to give you a minute or two, but I want you to look for patterns and I want you to look for common factors, and I'm going to take some answers.
All right, to pitch value.
Okay, I'm looking for answers just for the first, maybe the first for A and then for B. Guys, do you notice? I don't know if you've noticed, every single time I write down an answer, I underline it. Do you see that? Okay. That helps your teacher, when your teacher's marking your work, that helps your teacher see what you're doing. The other thing in maths also, we always try and work down and we put an equal sign on every line. We're not changing the value. We are just writing it in a different form. Okay, let's go. A squared minus 100, someone.
Oh, yeah.
Yeah. No, it's a difference of squares. Well done. Okay, I'm going somewhere else for x cubed plus 27. You can go close by, Ayanda. You don't have to run all day long. La. Yes. Okay. All right. Now it's getting slightly more interesting. Yes. Then. Well done. La. Okay. All right. So guys, do you see that this question's got like two steps? If you look when you've got a question like this one is maybe 2 marks. Okay. This one's probably 3 marks. And that will probably tell you, if you just did that and you stopped, you've got to say to yourself, was that worth 3 marks? No, that's not worth 3 marks. That's why this one's worth, yeah, that's why there's more to do. Yes. Yeah. Yeah. And are you finished? Okay. Can you factorize a sum of squares? X squared plus 4. No. Guys, you cannot factorize a sum of 2 squares. Well done. That is very, very well done. Guys, can I tell you that many of the learners that I teach, they will not get full marks for this question. They will either stop here, all right, or they will stop here. So when we finished factorizing something, we always need to check, can any of the factors factorize some more? Like here, this here can factorize some more. If you've done enough practice, x squared minus 4, you will say, ah, I know what that is. It's a it's a difference of two squares. Right, let's go with 5x cubed plus 5. Someone, please.
Mr. Paul, can you mute each other?
Yep.
Please mute each other.
Well done. Well done. Okay, very well done. This is a sum of two cubes. Okay, now I'm looking for an answer for this. And I want to remind you what I wrote up at the top of the page. Ball squared minus lightning bolt squared. Okay, because ball can represent anything. I want someone to tell me someone with a microphone. I want someone to tell me, what is this thing? 3x plus 5y all squared minus 2x plus y all squared. I want someone to put your hand up, grab the microphone and tell me, what is this? Here we go. Yeah, you've got the microphone. Okay. What is this thing? I'm walking along on the beach and I see fish squared minus triangle squared. It's a what? What is this? Guys? I want you just think of this as blob squared minus green blob squared. What is it? Well done. It's the difference of two squares. Okay, so what will I have in the one bracket? Guys, in the one bracket, if you've got the mic and anybody want to tell me, what will I have? How does the difference of squares factorize? Okay, yellow blob squared minus green blob squared. What do I have in the one bracket? Yellow blob.
Paul, can you
plus green blob.
Mr. Paul.
Guys, do you see what we've got here? We've got the green blob there. So this is like, think a squared minus b squared. A squared minus b squared. A plus b, and in the other bracket, a minus b. 3x plus 5y. Minus, now just pass up, because we've got to be careful, minus the green blob, 2x plus y. All right. And guys, look, can we simplify what's inside the brackets? Yes. 3x plus 2x, 5x plus 6y. Sorry, 5x plus 6y. And in this bracket, 3x minus 2x is just x, and 5y minus y plus 4y. All right, and there it is. Okay, it doesn't look maybe like it's the same thing. I promise you, if you multiplied all of this out and factorized it, you'd get to here. But do you agree? This is quick. We don't want to multiply it out. We want to recognize that this is a difference of two squares. And exactly that's why, guys, that's why I wrote the tennis ball and the lightning bolt. Okay, now we're now going to look at three terms. If it's got three terms, it could be a trinomial, three terms. Now, I want you to listen very carefully to this. This sign over here I'm going to call the second sign. I want you to write that down. Second sign. Second. Sorry, guys, I'm getting sick, which is not ideal. This sign over here is the first sign. Okay. Now, let's just read these two very important sentences here. If the second sign is positive, then both the signs will be the same, and they will both be the same as the first sign. Okay? If the second sign is negative, one sign will be positive and the other one will be negative. So now what I want us to do, I want us to write these down, all of these, okay? All right, yeah, okay. Sorry guys, I'm not going to do that one yet, okay? But I'm going to ask you to write down wherever I'm putting the brackets in. I want you to put the brackets in. Okay, and I want us to look now at at the signs. So listen carefully. I'm going to look at the second sign. Who can tell me, and I want you just to get the microphone, I want you to tell me, what will the signs be inside this bracket here? Will they both be positive? Will one be positive, one negative? Or will they both be negative? Both positive. Okay. Now, guys, the reason they're both positive, listen carefully. We look at this sign first. We always look at the second sign first. If it's positive, they will be the same as each other, and they will be the same as that one. Okay. All right. So now I want someone to tell me about the signs in this one over here. Will they be the same or different? Guys, we look at this back sign here. All right. We look at this back sign. If it's positive, they're the same. So what will they be here? They'll be different. And guys, just think about it. How do you get a negative answer? You get a negative answer by multiplying a positive with a negative. Does it make sense? It always makes sense. Okay, right. Let's look at this one. This is going to be an A and an A. All right. Now, talk to me about the signs. They will be the same as each other, and they will both be positive. What about this one? They will be the same as each other. Guys, remember what we're doing. We're looking at that sign first. All right? And if that's positive, then the signs will be the same. And they will be the same as whatever that sign is there. So here they will both be positives. Right. I want someone to take the microphone, and I want you to tell me about the signs in this one. What schools is this? What school are you from? So before no, keep the microphone. Keep the microphone. I want to talk to you, my friend. Just tell me. You didn't hear me ask you what school are you from? Okay, thank you. So can you tell me this one over here? Will the signs both be positive, both be negative, or will they be different? Okay, so no, I'm glad, guys. There's lots. I suspect there's lots of people in the room who haven't fully understood this yet. Who can explain it? Because maybe I haven't explained it that well. I don't want you just to tell me the answer. I want you to tell our friend from Senzo Gushle how you know. Okay, so in other words, explain how we're finding these signs here. I've explained it, but I want someone else to explain it. Yeah. Okay, so when this is a plus, they will both be the same as each other, and they will be the same as that. Well done. Okay, all right. Okay, I want someone now to explain to me, not just tell me the answer. How do I know what these signs are?
Oh, leg ne camera phone. Click on that.
What's negative? Are the signs negative? Are you saying that or not? You're saying that. Okay. You're not right. Okay. It doesn't matter that you're not right, but who can explain how I know what these signs are? They're not both negative. Guys, just listen carefully here. We are not just copying the signs from above. Okay. All right. Over here, you might think, oh, they're both positive, so they must both be positive. That's not actually what we're thinking. We're thinking start with the second sign. Who can tell me what's this going to be? Yes. It means the signs are not the same. Well done. One of them is plus, one of them is minus. Okay. All right, guys, I want you to go back to the inside cover where I'm hoping you've still got a little bit of space. In fact, you know what? Go to the back page, the very back page of your book. The back cover, you'll see page 20 is blank. Am I right? Yeah. I want you to write this down. Okay. I want you to write down like all of these. Okay, now these guys, these don't factorize necessarily, but I want us to just make sure that we've got the sign story correct. Because so far, sorry, these don't worry about writing them as equations. Sorry, I don't know why I'm writing equations. It's just out of habit. Okay, but okay. And underneath them, I want you just to write brackets. And I just want you to put in the signs in those brackets. We're not trying to factorize them, guys. These will not factorize. Okay, I've just made them up very quickly. I'm just interested in making sure that we completely understand how we are finding the signs here. All right. Okay, so this is the last thing we're going to do before we take a tea break. Okay, so who can tell me? Maybe you can just pass the microphone down a row. Okay, literally each person, we're going to go down the row. You're going to pass the microphone to the next person, and the next person's going to tell me the signs. Okay, so for the next one. Okay, so and I'm going to go down here, and then I'm going to go down here. All right, so first up, you've got the microphone. Tell me how you know what the signs are. Yes. They will be different. Well done. Hala. Okay, pass the microphone to the person next to you. No, okay, no, okay. All right. Tell me what you know. If you understand the rule, it's very simple. Which sign do you look at first? You look at the second sign. So this is positive, so it means what? They will be this, they'll both be the same as each other and the same as those one, as the first one. Right, well done. Pass the microphone to the person next to you. Okay. Guys, guys, seriously, this is not complicated. We've got to understand this. Okay. No one wants the mic. By your side. Everyone's scared now. It's so simple. Guys, I'm going to do something here. I'm going to highlight all these second signs because that's what we look at. Now, I'm going to write it down again. If positive, guys, listen. If positive, same. And same as first. Same as first sign. So we start at the back. Okay. If negative, different. Different, I mean, one of them must be plus, one of them must be minus. I promise you, we should be, if we understand this, we should be able to just fill in these signs. Okay. All right. So who's got the microphone? Tell me about the signs for this one over here, for number 3. Well done. Well done. Okay. It doesn't matter which way I put them, either a plus and a minus or a minus and a plus. Right. Next person. And I'm hoping that my friend from Senzo Bushler who didn't know earlier now knows. Okay. Right. Yes. Talk to me. Yeah. They'll both be positive because this is positive or because this is positive. Like, where do we look? They'll be the same as this one. You're absolutely right, but I'm just making sure you know why they're plus. They're plus because this is plus. All right. Okay, next person. Talk to me about the signs. Yes, someone, quickly, yeah. No. If the last sign is negative, what do we know? The signs are different, 1 plus 1 minus. Okay. All right. Unfortunately, what you just told me would be true if the last sign was positive, but not for negative. Right. Next person. Talk to me about the signs. Yeah. Correct. And what will they be the same as? They'll be the same as the first sign. Well done. They'll both be positive. Okay. Right. Next person. We've got a negative second sign here.
First bracket is going to be positive, second bracket is going to be negative.
Okay. Or the other way around. They're going to be different because that's negative. Okay. Well done. Okay. Right, guys. When we come back from tea, we're gonna use all of that to practice some factorizing. But use this idea. We've put the signs in. We're gonna use this idea of now trying to factorize these things. Okay. And I'm hoping we understand how these signs work. We're going to get a little bit more practice at it, but let's have a look. Now, what we do, we read from the back. We want factors of the back number that will second sign to give the middle term. So look at this. We want factors of 6 that add to 5. Factors of 6 that add to 5. You can just shout it out. 3 and 2. Does it matter which one I put where? No. I can put 2 here, normal. I could put 3 here. I must have a 2 and I must have a 3. Okay. Listen carefully and watch carefully. Factors of 24 that subtract to give 2. Factors of 24 that subtract to give 2. This guy's good at his numbers. 6 and 4. 6 and 4 subtract to give 2. Cordwa, I don't want 2, I want -2. So the bigger one, the bigger number must go with this sign. I must put the -6 and the +4. If I quickly check it, watch, I'm just quickly checking it. X times x, x squared. 4x and -6x. It's right. It's -2x and -24. Okay. I want someone else now. You've got the microphone right in front of you there. Factors, listen carefully. Factors of 14 that add to 9. Does it matter which one I put where? Doesn't matter. I'm asking the president with the microphone. Does it matter? Must I put the 2 or 7, or doesn't it matter? It doesn't matter. They're both plus signs. I can put it either way. Because, guys, remember, those brackets can swap around. A plus 7, A plus 2, A plus 2, A plus 7. Same thing. Okay. Now, I'm going to leave these ones for now. We're going to come back to them. I'm going to come back to these ones that we left out. What we're going to first do always is look for a common factor. Is there a common factor? What is it? It's 2. Okay. So what we're going to put inside? Sorry. What are we going to put inside? X squared minus x minus 6. Now, I want someone to take the microphone, and I want that person to cast their mind back to before t, and I want you to tell me about the signs that I'm going to put here. All right, someone who hopefully you all understand what we're going to do. Yeah. I don't just want the signs. I want you to tell me how you know. Yeah. Well done. The second sign is negative. So the signs are not the same. Keep the microphone. Just hang on to it for now. Now, listen, I want you to read backwards with me. Factors of that. Yeah, but listen, now let's just say it. Factors of 6 that subtract to give 1. Okay. And you said they are 3 and 2. Where must I put the 3 and where must I put the 2? Understand that I want a negative answer. So the bigger number must be negative. So what must I put over here? Where? Here. Correct. 3 and 2. Okay. All right. Guys, I want you to all try D and F. D and F require you to take out a common factor first. I want you to take out the common factor, and then I want you to think about the signs, and then I want you to see if you can find the factors. Okay, I'm looking for an answer for the first one. Okay, talk to me about the signs. Well done. Well done. Well done. The bigger one, so 6 and 5, all right. Guys, 10 and 3 are also factors of 30, but they need to subtract to give us 1. Okay, so it's actually 6 and 5, and you've absolutely correctly said the bigger one must get that sign of the middle term. That will give us the minus 1x. Okay, if we multiply this back, we get to this. If we multiply the 3 back in, we get to that. This here, this symbol over here, equals, is the most important mathematical symbol. We're not changing the thing. We are just writing it in a different form. Okay, let's get an answer on this one. Okay, Ayanda's going to be very fit at the end of today. She can run the Comrades Marathon maybe in June. Yeah. I want you to look for a common factor first. Oh, no, sorry. Nancy Kinga. This is my fault, guys. This here, I want you to change this P to a G. Sorry, man. Okay, I made this question up and it's not what I wanted it to be. Okay, so maybe you want a little bit more time, but just maybe you can still keep the microphone. Okay. Yeah, great. Thank you. Well done. Now, I want you to tell me about the signs and how you know what they are. Yes. And what are they the same as? Well done. When the signs are the same, guys, when the second sign is positive, both the signs will be the same as the first sign. Now, tell me what we're looking for here. I don't want the answer yet. I want you to tell me what numbers are we looking for? We're looking for? Yeah, you're telling me the answer. I want you to tell me, what are we looking for? We're looking for factors of 24 that add to 11. And they are 8 and 3. Does it matter which I put where? No. Okay, you can put 3 minus P minus 3, P minus 8, or the other way around. Okay. Okay, well done. Right. So, guys, now these ones here they're much more difficult, these ones. Okay, and I'm going to show you why. There's not a common factor. All right. Now we've got to try and work out what's going to go here and what's going to go there. Okay. This first one is not too bad because 2 is what we call a prime number. Okay. 2 can only factorize in one way. So it's going to be 2x in the one bracket and x in the other bracket. Because the signs are both positive, it doesn't matter which ones I put where. Now, listen carefully, because if we understand how this works, all right, we want factors of 6. Now, unfortunately, we're not going to read it like normal factors of 6 that add to 7. If you said that, you would want 6 and 1. 6 and 1 are not going to work here because the number that I put here is going to double. Am I right? When I multiply. The number that I put here is not going to double. So now listen carefully. I want factors of 6. One of them I'm going to double, and I'm going to add it to the other one, and I need to get 7. Okay, we've got your numbers are good. I know your numbers are good. I want to see if someone else can tell us. What are we going to have to put here?
Of 7, I've got 2x plus 3
Yeah,
and
x plus.
x plus.
So it can't. So we're not looking for factors of 7 because 3 times 4 would be 12. Okay, we actually want factors of 6, but one of them is going to double. You're very close. What must I put here to get the 6? 2, yeah. Guys, if we multiply this out, I promise you this is the right answer. Look at this. What's this product going to be? This times this. What will it be? The 2 yellow things. It'll be 4x. And what will these 2 blue ones be? 3x. And what's 4x plus 3x? 7x. Okay. Now, this next one is more difficult still. Okay. And the reason this next one is more difficult still is because I don't know if I'm going to use 6 and 1, Norma, 3 and 2. With the 10, I don't know if I'm going to use 10 and 1, number 2 and 5. Okay, now we've got to experiment. We've got to practice. We've got to try different things. Okay, and remember how you're going to know. You're going to multiply back and see. All right, I'm going to suggest we try 2x and 3x first. Now, I want you to experiment and see, can we make 10 and can we get the minus 19? And remember, the minus 19 comes from the outers and the inners. The minus 19 needs to come from here and here. If you've got it, if you can see how to do it, maybe you can put your hand up. So Ayanda can, yeah, okay, we've got a microphone there. Thank you.
Okay.
You want a -5 there. Okay. Okay, let's look at this, guys. What does this yellow product give us? Sorry, not the yellow product. The yellow product gives us 6x squared. Okay, which is right. But what does this product give us? Positive 4x or negative 4x? Negative 4x. And what does this product give us? Negative 15x. Minus 4 minus 15 minus 19. Hala, la. Okay, well done. Guys, this is difficult. Okay. Now, look at this one over here. Now, Nancy Kinga, because 12 has got lots of factors. Maybe it's 12 and 1. Maybe it's 2 and 6. Maybe it's 4 and 3. Also, the signs are different. So now I've got lots of experimenting to do. But what do I know about 2? The only way I can make 2 is 2 and 1. So maybe it's 2 and 1. Norma, maybe it's 1 and 2. Okay. Now, let's see if we can make the -5 with a 2 and a -1. Okay. And I want you all just to try. Okay. You've got to be patient. You've got to try different things. I'm going to just, I'm going to ask Ayanda to let you go, but I want to just give people a little bit more time to try. Okay. All right. Have you got it or not? Do you know the answer? You do. Okay. Give 1 more minute. All of you try, guys. See if you can work out what are the numbers that have to go here. Okay. Tell me what you've got. Yeah. Oh, I thought you wanted the microphone. No.
4x plus 1.
4x plus 1. Okay, now I'm not going to clap yet because I'm going to check. What's this product, guys? No, not 6. Product. Is it positive or -8? -8. What's this product? +3. What's -8 plus 3? -5. Hala. Well done. Okay. All right, guys, those are they're tricky, those ones. Okay. Now, also the thing is that, and we're not going to do all of these. I want you just to do E. Look at E. The first thing I'm going to ask you, is there a common factor in all these terms? Is there anything that's common in all of the 5 terms? No. When you've got 4 terms or more, it's probably going to be grouping. So we're going to try and factorize that. And separately, we're going to try and factorize that. I want all of you to do that. The one that I've underlined in black, what sort of factorizing is this? It's a trinomial. Okay. All right. I'm hoping you're going to factorize that quite easily. I actually think we've already factorized that today. And the other one is just a common factor thing. So I want to try this and see if we can just do this question. Okay, I want someone else Someone else. What I'd love for you to do, there's a sense of Bushler learner there. You're not giving it, okay, you're going to do it on Cliff. Okay, right. What I want you to do, my friend, is I want you to tell us, I want you to explain this as if you are now a teacher. Tell the class how you did this. Okay. Okay, second, carry on. Brilliant. Yep. So we're going to have different sounds. Do you want me to go like that? This one is 2. And this is 3. Because I want factors of 6 that differ by 1. And I want it to be a positive 1. This is 100% correct. Well done. Okay, carry on. This orange piece, what's the common factor? Yeah. Yeah. Now what? How many terms have we got now? We've got 2 terms, guys. Remember, terms are separated by plus and minuses outside of brackets. 2 terms. Is there a common factor yet? No. Let's say it together, nice and loud. Switcheroo. Let's try that again. Switcheroo. Yeah, switcheroo. So, yeah. Now, tell me what I'm going to do here. Yeah. And what's going to go in here? A minus 2. Okay. All right. We've done the switcheroo. We've changed 2 minus A to A minus 2. The reason we've done that is because we've now got a common factor. Do you agree that this question here is the same as this question here? Triangle A plus 3 minus B triangle. Do you agree? It's the same thing. Do you see that this is exactly the same thing? All I've done is I've written a triangle instead of the A minus 2. What's the common factor in this one? Triangle. So what would go inside the brackets? Plus 3 minus B. Okay, so tell us the final answer here. Okay, in a bracket, and then? Allah. Okay, now the reason, guys, the reason that we've been learning some factorizing is one of the reasons. There's a lot of reasons, but is to simplify fractions. Okay, can somebody give me a fraction that's equivalent of the same value as 4/12? Okay, right at the front here.
Okay. 6.
Well done. Can you give me, pass the microphone to the person next to you? Give me another one. 1/3. Well done. What about 11/33? Is that equivalent? Yes, because what we've done, we've multiplied the top by 11 and the bottom by 11. What about 110 over what? 330. Are those all equivalent? Yes. Okay. What about, and I'm going from the 1/3 here, what if I add 7 to the top and I add 7 to the bottom? Are these fractions the same? I added 7 and I added 7. They're not the same. Okay, this one's less than a half. This one's much bigger than a half. All right, we can't add We can't add and we can't subtract. Okay? So now, and I hope the teachers are listening, all we can do is divide or multiply by the same number. One of the words that a lot of teachers use, and all my colleagues at Michael House use it, and it's a dangerous word, they say cancel. Okay, I don't like the word cancel, and I'm going to explain why. Because if you're saying cancel, you might say, well, let's cancel those minus fours. I equally enter. You can't cancel the minus fours. Mathematically, the way you would get rid of minus 4, how do you get rid of minusing 4? You plus 4. Are you allowed to plus 4 to the top and the bottom to create an equivalent fraction? No, you can't do that. You can only divide. Now, we can't divide anything here because there are multiple terms. Cordwa, if we can factorize the numerator and the denominator, then we can divide, not cancel. All right, who's going to tell me how to factorize the numerator and the denominator? Yeah, let's go anywhere. Okay. Well done. Yeah. Okay. And yeah. Okay, well done. Now, and I want you to listen carefully. I'm gonna talk you through this now, guys. I don't like the word cancel, okay? And the reason I don't like the word cancel, if you cancel something, there's nothing left. We're not canceling. We are dividing by x minus 2 on the top and on the bottom. So the final answer now, x plus 2 over 2. Can I cross these out? No, I can't cross those out. Okay, because there's a plus sign here. I can only divide, not add or subtract. That is the final answer. All right. So now I want us to try, let's try all of these, A, B, and C. Okay. Because and notice you can't do algebraic fractions if you can't factorize. You can't factorize if you can't do products. Do you see? Everything is connected to everything else in maths. It's like a big jigsaw puzzle. Okay, in the back row, there's some lots of hands going up in the back row there. There's also some in the middle row. Here we go. We've got someone. Is this Senzo Buche? What school? Jabula. Sorry, Jabula. Yeah. Sorry. I see that you both got yellow shirts, but your ones, those ones are brighter. Yeah. 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 Okay. Halala. Now what? Yeah. Yeah. Well done. Halala. You see, guys, over here, we didn't have anything that we could divide. Now we do. What's our final answer? 3 over -2. Well done. This can divide. This can divide. 2. Guys, I just want to show you something here. Can I write this like this? Is that the same number? It's exactly the same number, guys. Positive divided by negative is a negative. A negative divided by positive is a positive. And I can even write it like this. Notice the minus sign can be there, it can be there, it can be there. Those are all the same numbers. Cordwa, don't put another minus sign. Now it's a positive. Okay, so just one minus sign. Right, now we've got to try and factorize this. Okay, and I'm hoping you guys know how to factorize this. Okay, I'm highlighting this. Don't use the word cancel. Right. We've got someone with the microphone. I hope.
X minus
Yep.
X plus
Well done. Difference of squares, eh? Yep. Allah, Allah. That is a difference of two cubes. And remember, guys, well done, because we've had to remember that from before T. Remember, this term here is this product with the sign changed. Okay, now what can I do? I want you to tell me what I'm doing now. I want that same learner to tell me, what am I going to do now? Well done. I'm going to divide by x minus 1 and x minus 1. I'm not going to cancel. I'm going to divide. What's our answer? It's x. Yeah. Well done. Can I cross these x's out? Okay, I can't do that. Okay, right, next up. This is what is this? Trinomial, yeah. I know some stuff about trinomials. Can you tell me, not just the answer, but can you tell me how you went about this question, factorizing this trinomial? Is the microphone working or not? Just talk? Yeah, it is.
X plus 2.
Okay, and what else? And?
X minus 4.
Okay. Guys, did we expect the signs to be different? Yes. We knew that'd be different because we had a minus there. Okay. Well done. You have factorized that correctly. Carry on all over.
X plus
Well done. Now what can I do? And I want you to tell me what I'm going to do. Well done. We divide those same brackets and we get 1. I now get x minus 4 over x minus 2. Can I cross these x's out? No. Okay. Right. Well done. Okay. Now, guys, the way we multiply fractions, okay, listen carefully to this. We just multiply the tops and we multiply the bottoms. We do not need to have common fraction types. So the answer to this is going to be 2 times 5, 10 over 7 times 3, 21. This one, 6 over, can it simplify? 3, we can divide the top by 2 and the bottom by 2. Okay, just be careful here. All right, when you've got mixed numbers, okay, and this is not really grade 10 work, this is more like junior work, but just reminding you, we're going to make this number into an improper fraction first. Okay, what we do, a little trick, a little shortcut, we multiply this 2 by this 2, we get, and then we add the 1, we get 5 over 2. I want to just quickly show you why that makes sense. All right, what 2.5 means? It means 2 plus a half. If we're going to add these, all right, 2 as a fraction is 2 over 1. So to get them to the same type of fraction, I've got to multiply the bottom by 2 and the top by 2. And do you see now where that comes from? Do you see that this multiplying this by this is basically what the way that we make this 2 over 1 into a fraction over 2. So it's that times that plus that. Okay, right. Now we're going to multiply the tops, 5, and we're going to multiply the bottoms, 18. Okay, now just a little look here. Sometimes if I ask you this, it's actually much easier to simplify it. I don't know what 18 times 55 is. I can't do that in my head. I could use a calculator, but I'm going to show you we can do this question without a calculator. I'm going to divide the top by 5 and the bottom by 5. What's 55 divided by 5? 11. What number can I divide here to make this a bit simpler? 2. 9. 9, guys. I'm going to divide by 9, and I'm going to divide by 9. How many times is 18 divided by 9? 2. What's my final answer? 1 times 1 over 2 times 11. Okay. Do you see that that's much easier than multiplying them and then dividing them? Okay, now let's look at this question. And don't be scared, all right? What we know is, can I do this? No, I can't do that. I need to factorize. Okay, so I want everyone to try this question. We're going to factorize everything that's not factorized. I'm going to put brackets around these. I'm looking for someone to take the microphone and to tell me how to factorize, how to finish this whole sum.
X plus 3.
No, just before you give me your answer, just tell me how you would, if you were explaining to your friend, to your study buddy, how are you going to tell them what signs you're going to put in here? Yeah. If it's positive, then what? They're the same as what? They're the same as the first sign. They both will be the same as that yellow one. So you're right. They're both going to be plus. Okay. And what are the factors of 9 that add to 6? 3 and 3. Okay, cool. Carry on. Okay, now which things can I divide? Not cancel, divide. Which things can I divide? And remember, you can only divide from the top to the bottom. Yeah, goes in once, goes in once. What else? Goes in once, goes in once. What's your final answer? Halala. Can I subtract an x from the top and the bottom of both? No, because fractions don't keep their value if you subtract. They only keep their value if you multiply or if you divide. Right. Okay, so now let's look at, guys, I'm sorry, I don't know why I haven't left you any space here. You're going to have to, this one, I'm not going to do both. I'm going to ask you to do this one. I want you to, you're going to have to work up. So in other words, try and see if you can factorize the top and the bottom, all right? And I'm going to remind you that if you've got more than 3 terms, it's probably grouping. All right, let's see if we can factorize this one. I'm looking for answers when someone's ready. Anybody ready to take the microphone?
A minus B
Yeah,
plus C. Minus
well done.
A minus
Well done. Okay, so tell me what I must write. 3. Okay, what have we done? A switcher? Roo. Well done. Okay, guys, normally don't work like I'm working here. Don't work across. Always in maths, try and work down. But we've run out of space here. I don't know why I didn't leave space. Okay, carry on. You can't divide yet. You can't divide yet because it's not factorized. Just careful, not 3a minus c. What's the common factor? A minus b into? Well done. And now what can I divide out? What can I now divide out? Well done. I can divide that and divide that. My final answer, 3 minus c over a plus b. Okay, now I'm going to, just because I can, I'm going to show you again. I'm going to show you on photo maths how I can do that. Okay, so let's just get this thing up and running. Okay, won't someone just bring me your book, especially if you haven't written too close to the question? Will you bring it? One of you just bring a workbook. Bring your workbook. One of you, anyone. Okay, so all right. So I'm a little bit worried because I'm not seeing your answer to this question. This workbook's not. I'm going to. Should I look back on the previous page? Hala. Okay. So this guy has been working. Okay, but he hasn't done this question. He hasn't done this question. Okay. All right. But guys, there it is. And there's the answer, guys. 3 minus c over a plus b. And you can even, if you want to, say, show me how you did that. All right. And notice it's done. It shows you all the working. Now, you might be saying, and maybe the teachers are saying, how, Paul, why are you showing our learners this? Okay. Thanks so much. The reason I'm showing you this, all right, is because I want you to understand that you can check your maths homework. All right. In a test, you're not going to have your phone. Okay. You need to know how to do the maths. All right. But I think it's quite helpful to know that you're getting it right, or to know I'm not getting it right. Let me see where I went wrong. Okay. And that's why I'm showing it to you. Okay. Right, guys. We're not going to have time to do all of them. Just remember that when you divide a fraction, what you do is you change the divide to a times, and you turn the second one upside down. This 50 is this 50 on the top or the bottom? It's on the top. It's actually over 1. What's the final answer here? 100. Now, I want you to just listen carefully to this. When you divide something in half, that's different to dividing by a half. Look what happened here. When you divided by a half, you actually got double. All right. So I think on Monday, I'm going to go to the headmaster, the principal of Michael House, and I'm going to say to him, will you divide my salary by a half? And he will probably say yes, because his maths is probably not as, maybe he's thinking, I'm going to pay Paul a half. That will be better. Okay. But dividing by a half actually means doubling. Dividing in half means halving. Okay. If you divide 10 in half, you get 5. If you divide 10 by a half, you get 20. Okay. So what are we going to do here? And now listen carefully. We cannot start cancelling or dividing anything. We've got to first change it to a times. 3 over x times what? 2x over 5y. We can, we can multiply and then simplify. Norma, we can simplify and then multiply. Okay, it doesn't really matter. Let's simplify first. Let's divide by x and divide by x. Okay, what's my final answer? It's 6 over 5y. All right. Now, I want you to do this one, and then I want you to do B. Don't be, everyone's going, how, where, hi-bo, where, my man. All right, guys, I want you to first write B as fraction divided by fraction. In other words, I want you to write the top fraction over here, the bottom fraction over here, and then I want you to change it to a times, and I want you to factorize. This is going to take a little while. I want you to do both of these questions. By all means, chat with the person next to you, see what they're saying. All right. All right, I'm looking for an answer just for the first one for now. All right, just the first one. There we go. There's someone there from Nyezaneni. I think you've got your hand up. Maybe. Yes. Yeah, she has. North Jersey. Oh, you're not going there. You're going somewhere else. Over here. With her pen in her mouth. Over here. with the red jersey on. It is a Nyezaneni, eh? Yeah, yeah. Okay. Right. Take it away. So, yeah, guys, don't laugh. Well done. Well done. Let's try and factorize this. Yeah. Okay, what can I divide out? Yeah, I can't divide x minus 2. There's only one x minus 2. I can divide that, yes. I can also, well done. I can also divide a y. Careful. What happened to the 9? And also we're multiplying, so it would never be over 6. No, because we multiply. 3 times 3 is 9. But what about this other 9? What about this other 9 on the top? Do you see this 9 over here? No, we don't want to do that. We don't want to multiply it back in. We want to try and simplify. We can. We divide by 9 and divide by 9. Well done. Hello, well done. Let's give a round of applause. Thank you. All right. Someone, please, to tell me how to do this one. All right. I'm not sure how well this one's going to work out, but anyway, we'll see. Yeah, guys, I think I don't think this question is going to simplify very nicely, but let's do it. Common factor of 2, and then what do I get inside? I get x squared. And can that factorize? X squared minus 1, guys, can factorize? Okay, good. Now, remember, I need to turn this upside down. So I'm going to put 5. Guys, you know what I think here? I'm going to ask you to change this question. I'm going to ask you to change this 1 to a 5. All right. Because I think I didn't make this question up quite as nicely as I'd hoped. But it doesn't matter. But let's say, what will I get now if I take out the common factor of 5? And on the bottom, I've got 8x4y cubed. What can I divide out now in terms of brackets? Yeah, I can divide out this x minus 1. Okay, right. Can I divide anything? Can I divide both the top and the bottom by 4? That goes in once and in twice. Okay, all right. So let's look at our answers now. All right. What can I divide? If I divide x cubed, if I divide the top and the bottom by x cubed, where will there be left over x's? Where, on the top or the bottom? On the bottom. So if I divide and I divide, there will be an x left on the bottom. Okay. And now if I divide a y out of the top and the bottom, where will there be spare y's? How many? 2. So I'm going to change this to a 2. Okay, it's getting a bit messy, but on the top I've got 5. On the bottom I've got 2xy squared. Okay, I've also got this x plus 1. Okay, a bit of a messy question. Right, guys, I want to quickly talk about adding fractions because in grade like 3 or 4 or 5 or 6, you learned about fractions. But I suspect, if you like the my class boys, many of you still don't really understand fractions. So I want to take you right back to the basics. If you're adding these two things, you cannot add them because they are different things. You can't add $2. So the dollar sign should actually be on the other side. It should be $2. Should be like that. $2 and R5. You cannot add that. Okay. They are different things. If you knew the exchange rate, you could change these to rands. Normally, you could change these to dollars. Normally, you could change them both to something else. Maybe like in Zambia, they use money called kwacha. You could change them both to kwacha. Okay. All right. We cannot add these two lengths. They are different things. These are centimeters. These are millimeters. We could change these centimeters to millimeters. 30 centimeters, 300 millimeters. Can I add them now? Yes, now they are the same thing and I can add them. All right. Does it make sense?
Yes.
It always makes sense. Can I add thirds to twelfths? No, they're different things. Can I change these thirds into twelfths? Yes. What must I multiply the top and the bottom by to make these thirds into twelfths? 4. 4 over 12. Is 4 over 12 the same as 1 over 3? Yes. It's the same number in a different form. Are these the same type of thing? Yes. Can I add them? Yes. Do I add the tops or the bottoms or both? Only the tops. 9 over 12. Okay. 9 over 12 is the answer. It can actually simplify because what goes into 9 and 12? 3. So if I divide by 3 and I divide by 3, I actually get 3/4. Okay, I'm not going to do this one. I'm going to do this one. These are different things. What denominator, what fraction type can I change them all to so that I've got the same type of fraction? In other words, guys, I'm looking for a denominator that all of these things will go into. I need a 2, I need an X, and I need a Y. So I'm going to try and make all of these fractions the same type. I'm going to try and make all of them 2xy, 2xy, 2xy. What? Now listen very carefully to this. What have I done to the bottom of this fraction? What have I multiplied by to get from x to 2xy? By 2y. So I must multiply this 1 by 2y. This fraction here, guys, is exactly the same value as this fraction here. Do you see that? Because if I simplified it, it would go back to 1 over x. I don't want to simplify it because I want the same fraction type. Now, what fraction type 3 over 2y is the same as what over 2xy? Well done. It's the same as 3x. Look at what I've multiplied the bottom by. Guys, look at this. 2y to 2xy. I've multiplied by x. So I must multiply the top by x. This one, what must I multiply y by to get to 2xy? By 2x. So when I multiply the 7 by 2x, I'm going to get 14x. Halala. Are they the same type of fraction now? Yes. This blue fraction, guys, is exactly the same value as that blue fraction. This green fraction is the same value as the green fraction. Okay, now I'm going to add them, and my final answer is going to be 2y plus 3x plus 14x, okay, all over 2xy. Can I simplify the top? Yes, I can. What's 3x plus 14x? 17x. 2y plus 17x all over 2xy. Does it make sense? It always makes sense. Okay. Yes. Oh, great. Where? Which question? This one. Which one? This one. Okay, thank you. Just tell us where we've gone wrong. Yes.
x x plus 2.
This factorizing 2x squared minus 2 is 2 brackets x minus 1 x plus 1. I know I left out a step here, but this is 2x squared minus 1, I think, eh? So this is 2x minus 1 x plus 1. So I'm not saying an x plus 2. This is a difference of 2 squares. Are we okay or not? Do you still think I've made a mistake? I don't think there's a mistake. And you know what I'm going to quickly do? I'm going to quickly just photo method. Also, I don't know if you saw, I changed the 5x minus 1 to 5x minus 5. Yeah, okay. Is it right? Okay, thanks. Okay, I mean, I appreciate you asking that I check. All right, because I do make mistakes. I promise you I make lots of mistakes. Guys, now look carefully at this. What fraction type must I have if I need an x plus 2 and an x minus 2? I actually need both of those. So I'm going to make this my fraction type. Ah. All right. Okay. Do you see what I'm doing? I'm trying to get them to the same type of fraction. Now, what fraction, what must I do to the top of this fraction, this left-hand fraction? What must I multiply it by to make it equivalent? X minus 2. Well done. Look at this. It's got an x plus 2. Now we've got an x plus 2 and an x minus 2. So we have multiplied by x minus 2 on the bottom. Nancy Kinga, you can't just multiply on the bottom. You've got to also multiply on the top. So this 1 is going to multiply with x minus 2. All right, I'm actually going to write it like that, 1x minus 2. All right, what must I multiply the 3 by so that I get the same fraction as I had over here? X plus 2, well done. Okay. All right, now, the big difference between the question and this line is I've got the same denominator. When I've got the same denominator, I can add these fractions. So they're both going to be over x plus 2, x minus 2. Now we're going to add the tops. Okay, and because I'm running out of space, I'm going to ask if we can see if we can add this in our heads. This is going to be an x, and what have we got here? 3x. So x plus 3x, 4x. Minus 2 plus 6. 4x plus 4. All right. And guys, that cannot simplify any further. You might be saying, can we factorize the top? Yes, we can. But then inside the bracket, we're going to get x plus 1, and it's not going to divide out with anything. So we can actually stop there. All right. Okay, now, and we're not going to do lots of these, but I want us to look at this last question over here, E. All right. In order for me to see what fraction type I need, because I don't want to take more than I need. All right. I'm going to factorize the denominators. So I want you just to, all of us just quickly factorize this. How does a squared minus b squared factorize? A minus b. Okay, a minus b, a plus b. And here I've got a 3 and a b minus a. And here I've got a 5 and I've got a plus b. Okay, right. Now, I want a common denominator. but I want it to be as small as possible. I want the lowest common denominator. So do I need an A plus B? Yes. Do I need an A minus B? Yes. Do I need a B minus A as well? No. I'm going to switcheroo first here. So have a look at this. I've got an A minus B. I've got an A plus B. I'm going to change this fraction to a plus, and I'm going to make this an A minus B. And now over here, I've got a 5 and a 2A plus B. Now let's look at what I need as a denominator that I can make all of them the same denominator, right? I need an A minus B, yes. I need an A plus B, yes. And what do I also need? I need a 2 as well. All of these fractions can be changed into this fraction type. Now, because I'm going to end up adding them, I'm only going to write this denominator once, okay? What must I multiply the top of this first fraction by to make it equivalent to this fraction? But guys, by 2, because I've already got the A minus B, I've already got the A plus B, I'm just going to multiply by 2. So 2 times 1. Okay. What must I multiply the 3 by to make it the same type of fraction as this? I need to multiply the 3 by a 2 and also by an A plus B. I've already got an A minus B. What I'm looking at here, guys, and I'm hoping it's making sense to you, I'm looking at what I've got and what's sort of been multiplied in. I need to multiply in by 2 because I've done that on the bottom and by A plus B. So 2 and by A plus B. And now lastly, what must I multiply the 5 by to get this fraction to the same type of fraction as this? Just an A minus B. Okay, they are all the same denominator now, so I've added the tops. All right, now the last thing I've got to do is just simplify the top. Excuse me. All right, and if you don't mind, I'm going to try and do this quite quickly. I've got a 2. Here, guys, I'm missing something. Here I've got a 6 times A and a 5 times A. Add them, 11A. Here I've got a 6 times a B, 6B, and minus 5B. No, 6B minus 5B plus 1B. Okay. All right, and there's my final answer. Okay. All right, guys, I'm going to leave fractions and we're going to get onto exponents. Okay. All right. Now, and I'm going to go back to asking some questions on the microphone. So can someone just tell me a very, very easy question? What does A to the 5 mean? What does it actually mean? No, just to the microphone to someone. Give the microphone to someone right there. What does A to the 5 mean? I don't want you to have to walk far. Yeah. Quietly, please, guys. Well done. 5 A's multiplying together. Now, these laws, all of these laws make sense. Watch this. If I've got A to the 5 times A to the 3, what this means is how many A's? 5. What does A cubed mean? How many A's are all together? All together, 8. All right, so the final answer, A to the 8. If I've got A to the 200 times by A to the 3, do I need to multiply all of those out? No. How many A's are here? 200. And here, 3. How many are there altogether? What's the shorthand for A times A? 203 A's? A to the power 203. So when we multiply numbers and the bases are the same, we add the exponents. Does it make sense? It always makes sense. Godwa, just be careful. Can someone tell me what is 2 to the 11 times 2 to the 5? I just want someone to take the microphone and boldly tell me the answer. Yeah. Okay, I don't want a calculator. I don't want a calculator. I just want to. What's 11 plus 5? 16. Hala. Okay. Now, the reason I asked this question, because and I want you to be honest, did anybody think that the answer should be 4 to the power of 16? One or two of you did, and I appreciate your honesty. Guys, we don't multiply these 2's by each other because these are not normal 2's. These are 2's with exponents on. A lot of people will say to me, Paul, I'm sure 2 times 2 is 4. Yes, it is. But this is not a normal 2. This is not a normal 2. What does 4 to the 16 mean? It means 4 multiplying by itself 16 times. We haven't got 4's multiplying. We've got 2's multiplying. All right. The next one. If I've got a to the 5 over a cubed, what does this mean? It means a over a. Now, remember, we can divide by a, top and bottom. We can divide by a, top and bottom. We can divide by a, top and bottom. Okay. What are we left with? A squared. If I gave you a to the 700 over a to the 695, do you need to write them all out and divide them? No. Where will there be spare a's? How many will there be left? There'll be 5 a's left and they'll be on the top. Okay. All right. Does it make sense? It always makes sense. Now, watch this. What if I've got a to the 5 and I've got a to the 7? Now, according to the rule, this will be a to the 5 minus 7. What's 5 minus 7? Negative 2. Kodwa, listen to this. If I wrote them all out, 5 a's on the top and 7 a's on the bottom, and I divide, where will there be spare a's and how many? There'll be some on the bottom. How many? 2 on the bottom. Okay. So look at this. A with a negative 2 as an exponent is the same as 1 over A with a positive 2 as an exponent. That is a really, really important idea. Okay. Is that right? Does that mean it's important? What? How do I say it? Balulegile. What? Balulegile. Allah. Okay. Okay. All right. So guys, that's that. Okay. If we've got a number with a negative exponent on, it can go to the bottom and become a positive exponent. Also, if we've got 17 learners and we've got 17 biscuits, how many do they each get? 1. Now watch this. If we've got a to the 7 and we divide by a to the 7, our law says we must subtract the exponents. Look at the law. It says subtract the exponents. We've been doing that. Don't worry about the law. It makes sense to subtract the exponents. A to the naught, guys, is 1. All right. I want to show you something here on a calculator. I'm going to see if I can find a calculator. All right. While I'm trying to find my calculator, can you guys tell me how old do you think I am? 65. Wait a minute. 70. How? 52. There's a friend. I've got a friend in the room. I have a friend. Someone thinks I'm 52. That's very nice. Okay, guys, I'll type my age into the calculator now. All right. There's my age. Okay. 56. Hi. Okay, but now watch. I'm going to go 56 to the power of 0. It's 1. Anything to the power of 0 is 1. Okay. All right. Okay, let's put the calculator away. And now, all right, so I'm going to go quite quickly over these next couple of little rules, and then we're just going to start simplifying some stuff. So have a look at this. If you've got a squared and you cube it, what does it mean to cube something? It means a squared times a squared times a squared. What, though, do we know? How many a's are multiplying all together here? 6. Okay. Did we get the 6 by adding or by multiplying these two numbers? By multiplying. So when we've got a power and we raise it to another power, we multiply. And that's what that rule is saying. Does it make sense? It always makes sense. When you've got, guys, when you've got something like this, this means xy times xy times xy times xy times xy, 5 of them. All right? How many x's will there be altogether in that product? 5. How many y's will there be altogether in that product? 5. So when you've got a product raised to a power, which one gets the power? Both. Okay. Kodwa. If you've got a sum raised to the power, this is not a squared plus b squared. Remember what I told you earlier. If I had 1 rand for every time I've seen this, and this is why learners do this, because look at this rule here. It says both get the power, but this is not the same thing. All right, this is a plus sign. We would have to write the 2 brackets next to each other and multiply them out. Okay, the last one I'm going to talk about very quickly. If we've got a fraction raised to a power, both the numerator, the top, and the denominator, the bottom, get the power. All right, I'm going to go and I'm going to ask you to do number 3. I'm also going to ask you to do number 4. Okay. All right, and we're going to look at those 2 questions. You might have noticed I left out number 1, guys. Number 1, you need to know how to add fractions. Number 2, you need to know how to multiply fractions. Okay, and I'm hoping we're okay with that. We're going to look at number 3 and number 4. It's all about the rules. It's just about obeying the rules of exponents. Anybody want to take the microphone and tell us how to do this? Just this first one. There's someone up there. Excuse me, guys. Sorry. Okay. Yes. Well done. Well done. He's subtracted exponents, guys. On this A, there's a little 1, which we don't bother to write, but you're absolutely right. And then what? La. I'm very, very impressed by that. Okay. Just here, Magangani. Right, guys. What we've done here is we've subtracted the exponents, but just understand, I'm just going to write it with the orange pen here. It's b to the -3 minus -2. And what is minus -2? It becomes +2. So -3 plus 2. Okay, now the only problem now is we want our answer with positive exponents. So how am I going to write this with a positive exponent? No, well done. Very, very, very well done. Okay. All right, guys, that's right. I want to show you, guys, I want to show you something here. I'm going to show you a different thing, but I'm still obeying the rules of this thing. This 24, so I'm just going to do it here with a blue pen just to show you a different method. The 24 is on top. I'm going to leave it on top. The A is on the top with a positive power. I'm going to leave it there. This B to the -3, I'm going to write the B to the -3 on the bottom next to the 6. I want you to show you what I've done. I've taken this B to the -3 and I've put it on the bottom. On the bottom, there was an A. I'm going to leave it there. And this B to the -2, I'm going to take up to the top, all right? And I'm going to make it a B to the +2. I'm hoping you're seeing what I've done here. I've taken this and I've moved it to the bottom. And I've changed the sign of the exponent. I've taken this and I've moved it to the top. And I've changed the sign of the exponent. Now, if you look at the answer now, we're going to get to exactly the same answer as our friend gave us now, because 24 divided by 6, cool. Where will there be spare A's? Guys, if I've got A to the 5 on the top and A to the A on the bottom, there'll be how many spare A's and where will they be? There'll be, no, guys, I've got A to the 5 on the top and 1 A on the bottom. When I divide out, I'll be left with how many A's? 4 A's on the top. Okay. I've got 2 B's multiplying together on the top, and I've got 3 B's multiplying together on the bottom. If I divide, where will there be spare B's and how many? There'll be 1 B on the bottom. There it is. Okay. Try this question and let's see if we can get some answers. Singaketa. We can move these A's and B's up and down and change the signs of the exponents, or we can do the sum and then work out any negative exponents first. So we've got choices. Yeah. Okay, so 2A to the 3 times A to the 3. Yeah. Well done. Okay, so guys, watch what's happened here. Brilliant. What's happened is that this A to the -3, which was on the bottom with a negative exponent, has come up to the top with a positive exponent. Okay, the other A cubed was already there. This B to the -1, which was on the top, has gone down to the bottom as a B to the +1. I don't need to write the +1, but I could. Okay, all right. Okay, times, yes. Well done. Well done. Remember, there's a rule that if you've got a power and you raise it to another power, you multiply those powers. Hala. This is going well. Carry on. On the top, if I multiply all this stuff, what do I get? Well done. Very nice. Guys, notice that there are 8 A's altogether on the top. There's 3 here, another 3 here, and another 2. The shorthand for writing 8 A's multiplying together is A to the power of 8. All right. Okay, now what? Well done. And you are 100% correct. Okay, very, very nice. All right. Okay, here we are dividing, and when we divide, we subtract the powers. Okay, all right. Now, if we turn over, not turn over, if we go to exercise 2, all right, our exponent laws are all about having the same base. So I'm going to quickly play you a song here. All right. So guys, that lady is singing about bass being like doof, doof, doof. Okay. I'm talking now about bass, B-A-S-E, but it's all about the bass. What we've got to do with these questions, okay, is we've got to try, guys, listen, we've got to try and get common bases. So we are going to try and write 12 as a power of prime bases. 2s, 3s, 5s, maybe 7s. I don't think we're going to need 7s. 2s, 3s, and 5s. We're going to try and write 9 as a power. All right. And we're going to try and write 4 as something to a power. And we're going to try and write 18 as something to a power. All right. Now, I want prime numbers that are going to multiply together to give me 12. So what would I have? I know this guy's numbers are good. He's going to tell us. Well done. 3 times 2 squared. Okay, goodness gracious. 3 times 2 squared. Okay. What about 9? Let's have someone else. 9. Yep. 3s. 3 cubed is not 9. 3 cubed. Yeah, 3 squared. Because remember, the power, we're not multiplying by 3. So it's not 3 cubed, it's 3 squared. Okay, 3 squared. Thank you. What about 4? 2 squared. What about 18? Well done. 3 guys, you might say, I know that 18 is 3 times 6, but 6 is not a prime number. 6 is 3 times 2. So 18 is actually 2 times 3 squared. Now, listen carefully here. If you've got a product and you've got a power, which one gets the power? Both. And if you've got a power and you raise it to another power, what are you going to do? Do you multiply or add? You multiply, guys. I'll remind you where the rule is. Here's the rule. You multiply. All right, there it is. So now let's use our exponent rules. Yes. That one. Mine. Is it not working? Thanks. So I think it's batteries, and I'm hoping that these batteries will work. Guys, try that question anyway. Okay, is it working? Okay, great. Thank you for that. Right. So guys, now we're going to use our exponent rules. All right. It's going to be 3 to the 2x minus 1 times 2 to the what? Well done. 4x minus, I'm not saying 4, I'm saying 4x minus 2. Times 3 to the 4, okay? And on the bottom, I'm going to have 2 to the 2x. I'm going to have 2 to the 2x. I'm going to have 3 to the 4x. Right, now, it's all about the rules, guys. All right? Because when I multiply and my bases are the same, I'm going to add the powers. So let's look at what happens when I multiply this by this. I'm going to get what? 3 to the 4x. Not minus 4. I'm adding minus 1 and 4 plus 3. All right. And guys, on the denominator, when I multiply this number, which has got a base of 2, by this number, which has got a base of 2, what will I get as my exponent? I'm going to add those, yeah. All right. And 3 to the 4x. Now. When I divide, what do I do to my exponents? I subtract them. So what power, what exponent will I get on the 2's? Negative 2, yeah. Because 4x minus 4x, luto, minus 2. What power will I get on the 3's? 3, okay? Now, nothing Kinga, I've got a negative exponent, angifuni negative exponent. So I'm going to leave this on the top, and I'm going to put this on the bottom with a positive exponent. Okay, what's my answer going to be? 27 over 4. All right, just quickly, I'm going to show it to you on photo maths because it's all about the rules, okay, of the exponents. So if I... Okay, I don't know, this might not be working. Okay, I don't know. Yeah, I don't think it's, I don't know what's happening yet. All right, guys, this is not, I'm not going to waste time trying to get to show it to you on photo maths. I promise you that answer is correct. Okay, right now, and guys, you'll notice I've left lots of questions that I'm not, we haven't got time to do all of them. And in fact, we're not going to get through even all the topics in the workbook. But remember, when we're simplifying fractions, we cannot, guys, listen carefully to this. Can I do this? No, I can't do this because, all right, because this is not factorized. Okay, guys, I know these sessions are very, very long. Okay, I'm well aware of that. The problem we have, all right, and those of you, no, you won't remember, but we used to do another session after lunch. I used to teach until 3 o'clock. It was too much. It was too exhausting for me. It was too exhausting for all of you. So now we only go till 1 o'clock. We've got less than half an hour left. And I know you're tired. I promise you, I'm more tired. Yeah, cool. I'm getting sick. Okay. But I'm pushing on. Okay. So I want you guys to try and push on as well. And let's get to the end. Okay. So guys, I want to try and factorize. Okay. Now, who can tell me what could I take out on the numerator as a common factor? And I want someone to take the microphone. I want you to tell me what you're going to take out as a common factor. And I want you to tell me what you're going to get inside. So guys, that little dot there means times. 2 times 3 to the m. All right. So watch this carefully. when you say 3m like that, or 3 to the power m. Yeah. Okay, so now we've got to be a bit careful. Remember, whatever I put here needs to multiply back to give me this stuff. Now, so what must I put inside the bracket so that when I multiply it back, I get what's in the I get the same as the numerator above. Well done. Guys, just watch this carefully. When I multiply 3 to the m by 3 to the 2, I get 3 to the m plus 2. Is everyone okay with that? That's our exponent rules. Okay, now what? What must I still have to get this term? Minus 1. Hala. But I'm going to show you, could I do this? Yes, because this is 1 anyway. And what's m plus 0? It's just m. Okay, so you could use 3 to the naught. Normally, you could use 1. Okay, right. What can I do now? What can I divide now? Guys, I want you to notice the top has got 2 terms. This line has only got 1 term. Ellie Lord, what? Just 1. What can I divide out now? The man with the microphone. I can divide that, and I can divide it there as well. Okay. Now I'm back to more normal numbers. What is 3 squared minus 1? No, just 3 squared is what? 9 minus 1 over 2. 4. Halala. Well done. Okay. I want everyone. All right, guys, I want everybody to try number 2. Everyone try number 2. And all I'm going to write here is factorize. Before you do any canceling, and we don't cancel, we divide. But before we do any dividing, we're going to factorize. Right. I'm looking for a volunteer. Is we're going to try and take something out as a common factor on the top and something on the bottom. I'm wanting someone with a microphone. All right. I don't want people shouting out the answers. If you want the microphone, put your hand up. Lots of people volunteering their friends. Yeah. Okay. Okay. So I want to. Yeah, but so that's what's there already. I want to try and factorize. What is in both the terms on the top? Okay, so I want you to try and take that out as a common factor. That's right. 3. 2 to the 2. Hala. Well done, guys. Just look at this. 2 to the m times 3 gives us that. 2 to the m times 4 times 2 to the 2. The 4 is just there, okay? It's multiplying in. The 2 to the m times the 2 to the 2. The bases are the same. We're going to add the exponents. Well done. Do something similar on the bottom for me. Keep going. Oh, that is so weird. Yeah, 2 to the power of m. Sorry, what did you say? 1, yeah? Two exponent 1. Well done. All right, guys, look at this. When we multiply this by this, we're going to add the exponents. So m plus 1. Well done. All right. Now, what can I divide out? 2 to the power m goes in once, excuse me, goes in once. All right. Okay. Now we're just dealing with some numbers. What's 2 squared? Times 4? 3 minus 16? Negative 13. 1 minus 2? Negative 1. Negative 13 divided by negative 1? Positive 13. Hala. Okay. All right. Okay, well done, y'all. That was very well done. All right. Now, guys, the last 10 minutes or so, okay, because we probably will finish a little bit before 1. I want to quickly talk about solving equations. Okay. All right. Now, there's two ideas I want us to think about. Okay, just listen carefully. All right. There's 2 ideas I want us to think about. When we solve an equation, all right, there's a metaphor. A metaphor is like an idea, all right, that we are doing and undoing. Okay, when we get dressed, okay, and you're probably gonna think this is a bit strange, but I'm just going to use 3 items of clothing. The first thing that we would put on, and I'm talking now as a boy, I'm going to put on my underpants, okay, my undies, okay, then my amabulukwe, my longs, okay, and then my shoes. Is it tratulo? Right. When you get undressed, guys, listen carefully to this. When you get undressed, which comes off first? The shoes, then the longs, and then last the undies. Okay. Right. Now listen, I know that sounds a bit strange, okay, but look at this. What's happening to x here? It's being multiplied by 2, and then we are adding 3. Now, listen carefully. Times x is being multiplied by 2, then adding 3. When I undo that, I need to undo it backwards. Okay, so what must I do first? Listen carefully. Multiply by 2, then add 3. If I come back the other way, subtract 3, then divide by 2. Okay, I'm undoing what happens to x. Minus 3, then divide by 2. And I want to show you how this is going to look over here. Now, the other thing, guys, is I want us to think of an equation as a set of scales that are balanced. The equals means they are balanced. Now, I'm going to do the same thing to both sides of this equation. I'm going to subtract 3 from both sides. Watch my hands. If it's balanced and I subtract 3 from one side, it won't stay balanced. If I subtract 3 from both sides, it will stay balanced. If I subtract 3 from both sides, what will the next line be here? 2x equals. If I subtract 3 from both sides, 11 minus 3, 8. All right. Now, x is being multiplied by 2. How do I get rid of time of multiplying by 2? On which side? Both sides. Okay. And I just, again, for the teachers in the room, I just want to talk about something here, because I think a lot of teachers are doing this. Okay. If I've got a new equation now, I've got like 3x plus 1 equals 7. Okay. A lot of teachers are using the following language, and I think it's not really helpful. So a lot of teachers are saying transpose this plus 1. Okay. The reason I don't really like it, it's transpose is a complicated word and it's not immediately obvious, okay? The other thing the teachers are saying, they're saying, take the 1 to the other side and make it a -1. I also, that for me is a little bit of a problem because what we're actually doing, we are subtracting 1 from both sides. All right? Is everyone okay with that? We're subtracting 1 from both sides. The reason I don't like take to the other side and change the sign, because now I'm going to take the 3 to the other side and I'm not going to change the sign. So that's why I don't like the idea of taking to the other side and changing the sign. What's happening to x? It's being multiplied by 3. How do I undo multiplying by 3? Divide by 3 on which side? Both sides. So the final answer, 6 divided by 3 equals 2. All right. Whenever we solve an equation, we can check. All right. Now, what's difficult or horrible about B is that there's some brackets. Do we know how to multiply out brackets? Yes, we learned that first up this morning. Okay. So we could get rid of the brackets. 2x minus 8 plus 1 equals 19. All right. Now, 2x, let's collect the like terms. 2x minus 7 equals 19. Now, I don't want this -7 here. What could I do to get rid of -7? I don't want you to say transpose. Okay. I want to. What's the undoing of minusing 7? Adding 7. I'm going to add 7 to which side? Both sides. What's the answer when I add 19 and 7? It's 26. And then, guys, so 2x is 26. How do I get rid of timesing by 2? On which side? Both sides. And I get my final answer, x equals 13. Okay. Nancy Kinga, we've got fractions. Okay. X is being divided by 2 over here. It's being divided by 3 over here. I'm going to, guys, I'm going to multiply. Now, listen carefully. What would I need to multiply by to get rid of dividing by 2? How do you get rid of dividing by 2? You multiply by 2. How do you get rid of dividing by 3? Multiply by 3. Now, listen carefully. I'm going to multiply by 2 and by 3 every term on both sides. Okay, now, so I want you to think about a 2 and a 3 up here. I'm going to write them and then I'm going to rub them out. What will divide out and what will be left? The 2 will divide out and the 3 will be left. So I end up with 3x, no fraction. Now I want you to think of that 2 and 3 next to this term. If there's a 2 and a 3 up here, well done. The 3 will divide out and I'll be left with 2x. And now I want you to think of the 3 and the 2 here. What will we get when we multiply 10 by 2 and by 3? 60. Okay, we're going to collect the like terms. 5x equals 60. Divide by 5 on which side? Both sides. Hala, x equals 12. Does it make sense? It always makes sense. Okay, now I want to show you this one, okay? Because now we're thinking, wow, this has now got variables in it. It doesn't matter. I want x, and I want x on its own. What can I do to both sides to get rid of this minus b? I can add b to both sides. What can I do to get rid of timesing by a? On which side? Both sides. C plus b all divided by a. Okay. Guys, our the boys at my class, a lot of them have got fancy calculators that can solve equations, but they can't solve these equations. And that's why I like these equations, because they really test that we know what we're doing. Okay, now let's look at E. Now we've got X's on both sides. We've got numbers on both sides. Can anybody suggest, and maybe with the microphone, if there's one thing that we could do to both sides that is going to make this better? Just one step. One step. Okay, something that you can do to both sides that's going to make this a little bit better. Okay, so what I'm seeing that you're doing, you're minusing 7x from both sides. All right. Yeah, okay, so I haven't done that yet, okay, because you've done, I just wanted one step, okay? And now, guys, what I've done, do you see what he's done? He's subtracted 7x from both sides, okay? The advantage now is that all my x's are on one side, okay? So now I've got minus 3x, and then what he said is he said 19 minus 3. What has he done to go from this line to this line? He's subtracted 3 from which side? Both sides. Okay, is this better or worse? It's much better because my x's are in one place. I want the man with the microphone to tell me, what's the last thing I should do to get x? On which side? Well done. 19 divided by negative 3. And there's my answer. Oh, sorry. Thank you. 16. Thank you. 16 divided by negative 3. Okay, you can tell him much. All right. Okay, now let's look at this one, guys. I'm trying to get x. So I want, yeah, I agree. Okay, guys, I'm trying to get x. I'm trying to get x on its own. Who can tell me a first step? Just a first step. A first step. Okay, just wait there. Equals d minus b. Well done. So this letter's done. Man. Okay, sorry guys. My brain is now. My brain is fried now. Okay, all right, guys, just listen carefully. All right, so this what's happened here? We've subtracted cx from both sides, and we've subtracted b from both sides. Now I want to get x on its own. Okay, Nancy Kinga, because halala. If we take out a common factor, x is in two places. What do we get? Equals d minus b. Okay, guys, just watch carefully. What? Yeah, wait. Wait, you're 100% right. But I just want to show the learners what you've done here. You've taken x from being in two places to being in one place. And that's very helpful. Now, what are you going to do as your final step? Well done. Well done. D minus B over A minus C. Okay. Right. Now, guys, I'm going to stop there. Okay. There's lots that I haven't done. All right. And I'm hoping that your teachers will maybe find time to do them with you. All right. Guys, listen, I'm going to try and do the solutions for this, and I'll give them to the teachers on the group. I haven't done the solutions yet, but I will do the solutions for the rest of the book. Okay, I'm going to stop sharing my screen. I'm also going to leave the meeting. So the people who are online, we're going to stop now. Thank you very much for joining. I appreciate that.